Example 5. Directions are still the same. We're trying to find all of the roots. I need to start off by using the rational root theorem. Remember, this just has us list all of the possible roots. So plus or minus the factors of my constant, which is 1, plus or minus the factors of the leading coefficient, which is 1. So really, the factors of 1 are just 1, so my only possible zeros are positive and negative 1. Don't let it throw you off that the degree is 3, so we know we need to have 3 zeros, but only 2 possible solutions, because with multiplicity, we could have repeated roots. I'm just going to go ahead and try testing out a positive 1. Remember, to test something, we should see whether or not we get a remainder of 0. So 1, 3, 3, and 1, because it was in standard form and I did not need any placeholders. 1 times 1 is 1. Add it, I get 4, 4. I can already see that this is not going to work out. Let's try a negative 1. How about that? So 1, 3, 3, 1. Bring it down. Negative 1 times 1 is a negative 1. Add, I get 2. Multiply negative 2. Add 1. Multiply negative 1. There we go. That's what I want. Now that I've used synthetic division to find a root, which is negative 1, I can factor it as x plus 1 and x squared plus 2x plus 1 equals 0. We've got it down to a quadratic, so we can go ahead and factor that using guess and check or a perfect square trinomial, because x would be your a and 1 would be your b. Middle term is 2 times a times b. You would end up either way with, I'm just going to bring it over here, x plus 1 times x plus 1 times x plus 1. So my 3 zeros are negative 1, negative 1, and negative 1. So really, if I think about the graph, I'm going to have one x-intercept at negative 1, and there is a multiplicity of 3, meaning that it will pass through negative 1. It would have that slightly bent shape. I plugged my function into Desmos, and there we have it. It's exhibiting the exact behaviors I mentioned, and because it was a cubic, we can see different end behavior. I would like you to try the try problem. I will give you a little hint before you begin that you will have to use synthetic division twice in this problem. When you are ready to check your work, please hit play. Alright, so for the try problem, I first used the rational root theorem, which is plus or minus all of my factors of the constant, which was 8, and then plus or minus the factors of the leading coefficient, which was 1. That gave me plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. I tested 1 first, and it worked for me. If you tested a different number, like negative 2, your work will look a little bit different than mine, but we should end up with the same conclusion. Okay, just wanted to throw that out there. So I tested 1 and got a root. That 1 gave me the binomial x minus 1, and my new coefficients gave me x cubed plus 2x squared plus 4x plus 8. Once again, I had to use synthetic division, still pulling from my original possible zeros. I ended up testing negative 2 and seeing that it did in fact work. So that negative 2 gave me the x plus 2, and remember, we have to bring down that x minus 1. It doesn't magically disappear. The new coefficients gave me x squared plus 4. X squared plus 4 is not factorable. Okay, so we've factored it as far as we possibly could. Now is the time to set each parentheses equal to 0. The first two are pretty easy. That just gives me 1 and negative 2. The last parentheses, x squared plus 4 equals 0. I'd subtracted 4 from each side, took the square root. Remember, when you take the square root, you must include plus or minus. And because it was a negative root, I have an imaginary solution. So my 4 zeros are 1, -2, 2i, and -2i. Even though that's 4 zeros, there's only 2 x-intercepts from our 2 real solutions. I'm going to show you the Desmos real quick. So when I plugged the equation into Desmos, I have 1 and -2 like we said. There was a multiplicity of 1 for each, so we can see it's passing through. The degree was 4, so it does have the same end behavior. It's behaving exactly how we predicted it would, which is pretty cool when you think about it. We know what the graph's going to look like just by knowing the zeros and the degree.